I'm Anil Kumar. We are exploring complex numbers. The question here is, describe the pattern in the values of I to the power of n where I belongs to set of natural numbers. Use the pattern to simplify I to the power of 22. Let me change this question a bit. Instead of natural numbers, I'll make it whole numbers since I want to include 0 also, right? So now the numbers are 0, 1, 2, 3 and so on, correct? So that's a change because I can take this power as 0 also, and anything to the power of 0 is 1. So anything to the power of 0 is actually 1, correct? So there's no harm in including 0. In fact, it should have been whole number here. Okay, so now let's continue. It says describe the pattern in the values of I to the power of n where n belongs to whole numbers. That means we are including 0. If I say natural numbers, we start with 1, 2, 3, 4. We could have done that also. Anyway, so let's see what the pattern is. So best thing is make a table of values. Okay, so we'll write n here and I to the power of n. We just calculate. So as I said, we'll begin with 0. So we'll write n as 0. And then we'll go to 1, 2, 3, 4, 5, 6 and so on. So if I have I to the power of 0, anything to the power of 0 is 1. I to the power of 1 is the number itself, which is imagine number I square, is minus 1, right? How about I cube? Now I cube you can evaluate like this. I cube equals to I square times I, right? So I square is minus 1, so it is minus I. So it is minus I. How about I to the power of 4? I to the power of 4 could be written as I square times I square, which is minus 1 times minus 1, and that is plus 1. So I to the power of 4 seems to be 1. How about I to the power of 5? Well, you could multiply I to the power of 4 by I and get I, which is right there. But we will do it here to show you how. It could be I squared times I square, which is 4, times I. And so as we did earlier, minus 1 times minus 1 times I, which is just I. So it is I. How about I to the power of 6? Well, I to the power of 6, we could write 3 of these. Okay, let's do that. Since we know what is I square, right? I square is minus 1. So it's better to write in terms of I square. I could have written cube of this also, right? So it is minus 1. Minus 1. Do you see a trend? So what we notice here is that these numbers repeat, right? 1i minus 1 minus I. 1i minus 1, and what should we get next? Well, we should get minus I if the pattern is repeating. So let's just check it out. So I to the power of 7 should be I square. We can cube this, right? Times I, correct? So I square is minus 1 cube times I. This is minus I. So we do get minus I. Do you see that? So the same pattern repeats. So this pattern repeats. Do you see that? So the pattern for us is that when the powers of n are 0, 1, 2, 3, 4, right? So it repeats after every 4, right? So the powers are 0, 1, 2, 3, 4, 5, 6 and so on. The value is I to the power of n is 1i minus 1 minus I. It is 1i minus 1 and so on. So this pattern repeats. So these 4 numbers repeat, right? So every power of 4 is actually 1 and then again it repeats, correct? So that is the pattern which we notice for I to the power of n. Do you get an idea? So that's the pattern. Now this pattern helps us to calculate any value of I to the exponent of whatever. So in our case, we have I to the power of 22. How will you evaluate that? Let's use this pattern, correct? So we have now I to the power of 22. Now 22 could be written as 20 plus 2. Since 20 is the power of 4, do you understand? So I to the power of 4 is 1, right? So we could write this as I to the power of 20 times I squared. I to the power of 20 is 1, I squared is minus 1. So it is 1 time minus 1. Do you see that? And therefore, this should be minus 1. So it is a number which is here, right? To the power of 2. Do you get the idea? So that is how you could easily calculate any power of I. So as an exercise, what you can do is, let's say, let me write down a question for you. Evaluate these terms. I to the power of 65, I to the power of 99, I to the power of 234, let's say, just any number. Use this rule. So basically divide by 4, and whatever remainder you get, that power of I will give you the answer, right? So basically what we are doing is divide by 4, and whatever is the remainder, that becomes the exponent. Do you get the idea? So the remainder is the exponent. That should be the answer also. So the rule here is that I to the power of n is equals to I to the power of n divided by 4, right? So divide by 4, and when you do that, you'll get a remainder, right? If you don't get a remainder, that is to say, if the remainder is 0, then your answer is 1, right? So whenever you divide a number by 4, the remainder is 0, 1, 2, or 3, correct? Those are the remainders. And based on these remainders, you can find the result, which will be I to the power of remainder. Do you get the idea, right? So that is how you should be evaluating I to the power of any number. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.